So for the area moment method, this involves the area of your moment diagram. So again, itong area moment method na to, we need your moment diagram. Paano kunin yung moment diagram? We've discussed that in the first topics. So here in moment diagram, we have theorems to support our method. So for theorem 1, the angle between the tangents at 2 points A and B of the elastic curve of a beam equals to the area of the moment diagram between A and B divided by the flexural rigidity EI. What do this theorem 1 mean? Let's say you have your beam AB. So if I'm going to draw my elastic curve, again, yung elastic curve natin, that is an exaggerated diagram. So let's say from yung beam AB natin is subject to an external load. So yung elastic curve niya, it looks like that. If I'm going to draw a tangent line passing through A and a tangent line passing through B, yung angle between the tangent lines, we call that your slope AB. So as per theorem 1, slope AB is equal to the area from A to B over EI. But what is this area? Again, since moment area method or area moment method deals with your moment diagram, if I'm going to draw the moment diagram of that beam, it looks, let's say, for illustration lang, yan yung moment diagram ng beam AB. So yung tinatawag natin dito na area AB, itong area AB na to, this pertains to the area between A to B of your moment diagram. Okay? That is theorem 1. For theorem 2, the deviation of B with respect to a tangent drawn at A, or TBA, in a direction perpendicular to the original position of the beam is equal to the area of the moment diagram between A and B multiplied by the distance from B to the centroid of the area of the moment diagram divided by the flexural rigidity EI. So what do this theorem mean? So yung distance from your point B, doon sa may elastic curve, hanggang doon sa may tangent line passing through A, we call that your deviation of B with respect to A, or TBA. Yung namang distance from point A hanggang doon sa may tangent line passing through B, we call that your deviation of A with respect to B, or TAB. So according to theorem 1, the deviation of A with respect to B is equal to the area AB multiplied by XA. And that deviation of B with respect to A is equal to the area of AB multiplied by XB. What do this area AB mean? Again, itong area na to, this pertains to the area between A to B doon sa may moment diagram. Yung XA na ito, that XA, kung doon sa may moment diagram, that is your centroid. Yung distance from point A hanggang doon sa may centroid ng moment diagram, that is XA. The distance from point B hanggang doon sa may centroid ng moment diagram, that is XB. So, here in area moment diagram, we have to take note of rules of sign. So, for the deviation, positive ang deviation natin if the deviation is below the elastic curve. Kapag naman yung deviation ay nasa taas ng elastic curve, that is a negative deviation. And you have to take note also, kapag sa slope, kapag counterclockwise, that is positive. Kapag clockwise, that is negative. Again, itong sign convention na to, this is for slopes. Okay? Then, for the deviation, positive ang deviation kapag yung ating TB or yung ating deviation ay nasa baba ng elastic curve. Kapag naman yung deviation ay nasa taas ng elastic curve, that is a negative deviation. Okay? Take note of these sign conventions. Kailangan natin to as we go on with our lesson. So, let's have this example. From given beam shown subjected to a moment of 12 kilonewton meter at A, determine the slope at B, deflection at the midspan, location of the maximum deflection from B, and the maximum deflection of the beam. So, sa problem na to, na yung support reactions are already given, that is 2 kilonewtons for A and B. And we have a moment at point A that is equal to 12 kilonewton meter. So first, you're required to determine the slope at B. Paano makukuha yung slope at B? Let's draw first. Di ba, area moment method deals with your moment diagram. So let's draw first the moment diagram of our beam AB. Paano ulit natin kinuha or dinrawing yung moment diagram in the previous lessons? First, we drew the shear diagram. May pababa tayong 2 kilonewtons. Then, since walang load from A to B, that's a straight line, then back to 0. For the moment diagram, that is the area of our shear diagram. And ito ang nakuha kong itsura ng aking moment diagram. Bakit pataas? Kasi po clockwise yung direction ng aking moment at point A. So, since na-drawing na natin yung moment diagram for this problem, we can now solve for the slope at B. How do we do that? I'm going to draw my elastic curve. So, yung aking beam AB most likely will deflect like that. So, ang elastic curve ko, yung nakikita nyo dyan sa screen ninyo na broken line. Yan. So, yung ating deflection at midspan, since point C is the midspan, yung deflection na tinatawag natin dito, di ba originally yung point C nandito? But due to the moment of 12 kilonewton meter, beam mabadi jay beam tayo, nag-deflect isuna, and the distance from the original point of C hanggang dun sa may deflection, that is the sigma C, or yun yung deflection at the midspan. Okay? Since slope ang hinahanap natin, if I'm going to draw a tangent line passing through B, yung angle from the original beam hanggang doon sa may tangent line, that is the slope at B. Okay? Bakit ito naging deviation of A with respect to B? Di ba ito si point A? Para madali yung maalala ang deviation, yung nandito sa may numerator na to, that is the point on the elastic curve. Yung point dito sa may denominator, yan yung point kung saan nyo dinaan yung tangent line. So in this case, yung tangent line ko, dinaan ko siya sa may point B. Kaya yung denominator ko dito yung point B. And since ang distance na to is from point A, and this point is on the elastic curve, kaya yun yung nasa numerator ko. Okay? So, going back to this, since ang first na hinahanap natin is the slope at B, yun yung angle na ito. Now, if you try to look at this diagram, at this free body diagram, ano ang gagamitin ko to solve for the slope of B, or itong angle na to? Itong angle na to. Ano ang gagamitin kong function para makuha ko itong slope at B? Looking at that diagram, it looks like triangle siya, di ba? Triangle. And since triangle, when we talk about triangle, ang unang pumapasok sa isip natin is trigonometry. So, anong function sa trigonometry ang pwede kong gamitin para makuha ko yung slope at B? Since we are dealing with slopes and not angles, hindi angles ang sinusolve natin, but the slope or yung rotation ng ating point B. If you try to review your trigonometry, if this is theta, Ang opposite nito ay si division of A over B. And ang adjacent nito ay yung distance na 6 meters. Kung if you try to go back to your trigonometry, ang function na maiisip ko is the tangent, right? Anong sabi sa tangent? Di ba during your lower years, tangent theta is equal to opposite over adjacent. Now, we're going to use the same relationship in here. But, since we're not dealing with angles, we're dealing with slope, alisin natin itong tangent na to. So, tangent, so the slope at B now is equal to the opposite, which is the division of A with respect to B over yung ating adjacent ay 6. So, we're going to use this equation para ma-solve natin yung slope at B. But, the question here, what is the value of this division AB? Kasi kapag alam ko na itong value ni division A with respect to B, makukuha ko na yung aking slope at B. But how do I solve for the division of point A with respect to B? Now, going back to Theorem 2, anong sabi sa Theorem 2? Ang sabi sa Theorem 2, for the division of A with respect to B, that is equal to the area from A to B multiplied by XA. So, how do I get this area from A to B? We're going to use your moment diagram. So, the area from A to B, yung dito sa may moment diagram, that is a triangle. So, if I'm going to get the area of the triangle that is equal to 1 over 12, 1 over 2 of my base 6 and my height is 12. But what is this XA? Paano ko nakuha itong 2 na ito? Itong 2 na to, that is your XA. Again, going back to Theorem 1, XA, that is the distance of point A hanggang dun sa may centroid ni moment diagram. Diba, since dito sa may moment diagram, ang ating shape ay triangle, ang centroid ng triangle ay itong point na to. And from your geometry, the centroid of a triangle is equal to 1/3 of your base. Ano yung reference ng 1/3? Malagip yung ba na ito during your geometry? Itong centroid ng triangle that is equal to 1/3 of your base. And your base is 6. So, 6 divided by 3, dun ko nakuha si 2. And if you try to look at this diagram, area of AB, kung ano yung numerator dito sa may division, yun yung magiging basihan ninyo sa pagkuha ng X. Here, the division of A with respect to B, ang numerator nyo is point A. So, yung magiging X nyo dito is from point A. Okay ba tayo dito sa kung paano ko nakuha yung value ng XA? Division of A with respect to B, if you put that in your calculator, that is equal to 72 over EI. And as I've said a while ago, di ba yung pagkuha natin kay slope B, that is equal to the division of A over the division of A with respect to B over 6. So if you're going to substitute the value, your slope at B is equal to 12 over EI. This is your final answer for the slope at B. If we go to the deflection at point C, again, ang kailangan kasi natin dito sa area moment method is your moment diagram and your elastic curve. So for the deflection at C, again, pag titingnan natin dito sa may diagram na to, kung saan nandun si elastic curve, yung hinahanap natin dito sa may deflection at C is this point. So how do I get this one? Again, using your knowledge in ratio and proportion or this same triangles. Using your same triangles, the bigger triangle ay itong triangle na to. This is your bigger triangle. And your smaller triangle is this one. So using your knowledge in ratio and proportion or similar triangles, masosolve ko si deflection at point C. Now, we know from the moment diagram that the height of our triangle for the moment diagram is 12. Nilagay ko lang si E over EI kasi we are dealing with deflections and slopes. Same true with this one. Itong 6EI na to, that is the height of this smaller triangle. Okay? So again, for the deflection at point C, using your ratio and proportion, yung distance from point C to point D over 3 is equal to TAB over 6. Na-gets yun no? Kasano ka naala dito before I go to the next? Okay. So, maalak di jay si apay ba nga nagkastinak? Di ba daytoy gamin deflection ni C, maalak daytoy basta amok jay value daytoy distance CD kan daytoy division CB. So I need to get the value or the distance from C to D. Tapos alak jay value ni TCB. Tapno maalak jay deflection at point C. So, maalak DJ CD using similar triangles or ratio and proportion. Nasolve tayo tatay JTAB which is equal to 72 over EI. And from that, my CD is equal to 36 over EI. So, amo kon yung value ni CD. Now, I need to get the value of my TCB. Kasi from that diagram, the deflection ni C that is equal to CD minus JTCB. Do you alak the deflection ni C? Nasolve ko the value ni CD. I need to get the value of my deviation from C to B. How do I get that? From Theorem 2, ang sabi sa Theorem 2, the division of point C with respect to B is equal to the area from C to B multiplied by XC over EI. Now, in your Theorem 2, sa pagkuha ng equation under Theorem 2, di ba hinahanap kasi natin dito is the division from C to B. How did I get that? This is now point C. Originally, si point C nandito. But due to your moment of 12 kilonewton meter, yung point C ko, nandito na siya. So, from this point, point C, hanggang dun sa may point, kung saan dumaan yung ating tangent line passing through B. That is your division of C with respect to the tangent line passing through B. So, since TCB daytoy, the area nga i-consider yung tata, that is the area from point C hanggang point B. The area lang nga i-consider you. Now, what is my basis for the value of my X? For the value of your X, looking at your moment diagram, if the centroid of your triangle is this one, yung XC na to, that is the distance from the centroid of your triangle hanggang dun kay my point C. So, if you look at this diagram, itong distance na to is 1/3 of 3, which is equal to 1. So, if I'm going to substitute that here, the area of the moment diagram from point C to point B is 1/2 of your height. The height of my triangle is 6, and the base of my triangle is 3. The value of my XC is 1. If you input that in your calculator, your TCB is equal to 9 over EI. And sabi nga natin kanina, for the deflection at point C, that is equal to CD minus TCB. If you substitute all the values, your CD is 36 over EI and your TCB is 9 over EI. Therefore, the deflection at point C is equal to 27 over EI. And so for the location of the maximum deflection from B, again, if I'm going to draw the shear moment and the elastic curve of your beam, the location of my maximum deflection ay, let's say lang, for this problem, ang aking maximum deflection ay nandito kay point E. Again, yung point E ko ay malapit siya sa may midspan. Hindi siya eksakto doon sa may midspan, pero malapit siya sa midspan. Hindi ko alam kung saan eksakto yung aking maximum deflection, but I'll assume that that is in point E. So I'll say that my maximum deflection is at distance x from B. And my maximum deflection, since nandun siya kay my point E, ito siya. From this point E, dun sa may elastic curve, hanggang dun sa may tangent line na passing through B, that is my TEB. So again, parang yung ginawa natin in the preview for the deflection at point C, makukuha ko yung maximum deflection basta alam ko yung distance ni EF. So if I'm going to use again yung relationship ng, I'm going to use the slope at B. Yan. So for the slope at B, I used theorem 1. Again, ano ang sabi dun sa theorem 1? The area from E to B, the area from E to B, looking at your moment diagram, that is equal to 1/2 of x to x over EI. So yung slope at B ko is equal to 12 EI. From there, makukuha ko na si x is equal to 3.46 meters from B. So yung aking maximum deflection ay nasa 3.46 meters from point B. Another requirement for this problem is your maximum deflection. So how do I get that one? Again, using your ratio and proportion, TAB over 6 is equal to the distance of E to F over x, wherein that x is equal to 3.46. So, na-solve na natin kanina yung TAB, which is equal to 72 over EI. So, I can solve for the value of my EF, which is equal to 41.52 over EI. Then, I need to get the value of my TEB para makuha ko yung maximum deflection. Again, from this equation, this is from theorem 2. TEB. Again, paano nakuha yung equation na to? This distance from point E, yung point E ko doon sa may elastic curve hanggang doon sa may point kung saan dumaan yung tangent line, that is TEB, which is equal to the area from E to B multiplied by x. Again, kung ano yung letter dito sa may numerator, yun yung magiging basis mo for the determination of your x. So substituting this, the area from E to B is equal to 1/2 of x times 2x. Your xe, that is equal to 1/3 of x. Diba ang centroid kasi ng triangle or yung triangle between E to B, the centroid of the triangle is here. Again, from your geometry, that distance is equal to your 1/3 of base. And your base here is x, which is equal to 3.46. If you're going to substitute the values in your calculator, your TEB is equal to 13.81 over EI. And we can now get the value of our maximum deflection, which is equal to EF minus TEB. That is equal to 27.71 over EI. Let's have another example, barong magets you. The EI of the cantilever beam shown is 54,000 kilonewton meter squared. Determine the slope at B and deflection at B. This is a cantilever beam. The very first thing you have to take note, no area moment method, syempre, no naalayan namin nga reactions niya, i-drawing nyo yung moment diagram. Nuwalpas nyo nga drawing yung moment diagram, i-drawing yung nga yung free body diagram na the elastic curve. For my case, this is an exaggerated diagram. So, dito yung elastic curve na, it will look like that. Now, in dealing with cantilever beams, when we say cantilever beam, the support na is a fixed support, tapos free end is una, may isang end na. Okay, that is a cantilever. Now, for the elastic curve of a cantilever beam, since fixed the support tayo dito, deflection tayo, haan nga diretso nga curve. Di ba no, pansinan nyo gamin, no, simply supported beam, when we say simply supported beam, hinge kan roller is una. No, i-drawing mo elastic curve, it is simply supported beam. Itipay lang rugrugina, bend nga dagos isunan. Kasta iti elastic curve, iti simply supported beam. Ngam no ti beam mo is cantilever beam, wherein the support kat fix. Iji ayan ti fixed support, haan nga dagos nga ag-curve iso na kasla dito nga point. No pansinan nyo, no fixed support, ti style na di elastic curve, ag-straight pay lang iso na ijay, then at a certain point, santo agrugi nga ag-curve iso na. Kas di ti itsura ti elastic curve, no cantilever beam. Okay tayo ba ijay?
Yes, sir.
Baka manan gamin mag-quiz kayo ngay fixed support iso na bigla kayo nga curve. Always take note no fix the support iti elastic curve na ag straight pie before nga agruging ag curve. Okay? So this is my elastic curve for the cantilever beam. Now since slope at B tibirbirukan tayo, I'm going to pass a tangent line at point B. That is my tangent line passing through B. Anya ulit data nga B nga data. Iso di data diagram nga makita yun. Since the slope at B tibirbirokop, I'm going to pass a tangent line dun sa my point B. Now, if you try to draw, tapos DJ green nga diay, that is the tangent line at point A. Now, since fixed support daytoy, if I'm going to draw a tangent line passing through point A, that is merely a straight line. Okay? Then, the angle between the tangent line passing through A and the tangent line passing through B, that is your theta AB as discussed in theorem 1. Ay nagtagaran di slope at B. Paano ko siya makukuha? That is my slope at B. Makita yun yung difference? Ay makita yun dito diagram na kasanok nga naalan ni slope ka ni B?
Yes, sir.
So if you try to look at that diagram, kasanok nga maalan ni slope at B? I need to get the value of my theta AB. Bakit ko kailangan kunin yung ito? Why should I get this one? If we try to look at this diagram, the whole diagram, makita yung nga J theta AB equal iso na kani theta B. Why? Since the tangent line is passing through B, the slope at this point is the same slope at this point. Since agpapada nga slope di, therefore, dj theta AB, that is equal to the theta of B, slope at B. So I need to get the theta AB. Again, under theorem 1, the theta of AB is equal to the area of AB over EI. Itong area na to, again, that is the area doon sa may moment diagram. Nag-atid tugmat ulit man ang solution ko, no, i-drawing ko pa t-shirt, tapos ang moment diagram na. And I have included in your notes itong diagram na to. This is to simplify your computations, tapno ag direksyon tayo ija yung moment diagram, ha? Kayo nga ang drawing t-shirt diagram. And paano gamitin itong diagram na to para ma-drawing natin yung ating moment diagram? So, since ang hinahanap, ang hinahanap kasi natin is the slope at B. Agpili kayo tatan, slope at B ti birbirokan tayo, agpili kayo ti side na i-consider you, either left side or right side. Ang niya ti kahit nga sa uwan ijay. For me, no pili up iti left side, i-consider ko garo din haan nga exist dito ayan ti left side. Dito point B ta agbalin nga reference ko, tapno na bipit si computation ko, tapno maalang di slope at B. So, lang nga kumbaga pinabasit ko di JBIM ko. Imbis nga tipim ko may kat ABC, agbalinan nga JBIM ko kat AB. Tapno lang maalak di slope ni B. Since slope ni B gamit ti birbiro ko kat diagram tatay nga nakita tayo. Ito nga diagram. Maalak di slope ni B, basta amok dito yung slope ni AB. And the slope ni AB is equal to the area from A to B. Therefore, haan po garon na kailangan di area ni B to C. Tama? Since haan po na kailangan di area ni B to C, ikatak garon di ayon. Tapnot iti, ayan lang ti focus po, di area between A to B. Since the naging focus ko is from A to B, aminan nga external loads, dito right side ko, haan po napanpansinan di ay. Tapno masimplify yung computation ko. So how will I draw or kasano tagbalin nga itsura ng moment diagram from point A to point B? Since indikat ko dagijay external loads dito right side ni B, ti agbaling tata nga reference ko ni point B. So, if I'm going to draw my moment diagram, anya data nga triangle nga data, ti height na kat 180. Kasanong naala data nga triangle? Again, this is already the moment diagram. If you try to look, ito'y dagito'y agbirok kayo dito from 1, 2, 3, 4. Let's consider first dito'y 30 kilonewtons nga dito. So, no, once gayam na nag-cut kayo dito or nagbalin nga reference yung ikot ni point B, pag i-assume yung nga dito yun nga point nga ikot agbalin nga fix. Okay? Agbalin nga fix di ayon. So, kita ni dito diagram 1, 2, 3, 4, ay na dita nga diagram, di padpada na nga ikot kastoy. Dito ni point A, dito yun, di agbalinan nga fix ni point B. Tapos, adda iti concentrated load dito nga 30. Oh. No, dita diagram 1, 2, 3, 4, ay na dita DJ kaspadpada na dito nga diagram. J diagram 2. Bakit slagpada dito eh. Daytoy na-encircle lang ti kulay red, padpada na daytoy. Haan naman na padpada, kita nyo, di may sanga and fix. Di may sanga and fix. Di may sanga and, at dati concentrated load. ito yung may sanga and concentrated load di ay. Look, agsabali na lang gamitin direksyon. Dito'y diagram number 2, pababa ni direction ni P. Ngam dito'y ayan ti diagram nga inaramid ko, pangato di 30. Ngam agpada da nga concentrated load. Now, I'm going to use this diagram dito'y number 2 nga dito'y. I'm going to use this kasi halos agpada da dito'y. So, DJ kano moment diagram na, dito number 2, it looks like this triangle. Now, since kasi the orientation na dito number 2 is DJ fixed support ada dito'y left, tapos DJ concentrated load ada dito'y right. Ngam kanya tayo baliktad, di ba? DJ fixed tayo ada iji right, tapos di concentrated load, ada ije left. No kasi garot, baliktadan tayo lang, daytoy nga triangle. Di jay ayan ti at dug, ada ije ayan ti fix. Since iba tatay, inikat kon di adan ti right side, agbalin garod nga fix ni B. Ikatan yun man, daytoy ni nga fix nga daytoy tao kayo nga maulaw. Tapno ti fix support tayo na lang kat adat ti kan ni B. So, ito, ayan ni B, ada jay didakdakkel nga side, ay jay height iti triangle. Then, since dito diagram number 2, pababa ni P, ti direction di triangle ko pat babamot lang. But since dito diagram tayo gamin, pangato ni 30 kilonewtons, iso nga di triangle ko garon, pangato. So, from 30, nimato di jay line ko hanggang dito nga point. Nag-gets tayo no kasano ka na-drawing dito moment diagram di jay 30 kilonewtons.
Yes, ma'am.
So the height of my triangle is 30 times 6. Kasano ka naala dito 30 times 6? Surutok lang ulit di jay adat to ayan ti diagram. Ano ti ko na diagram? The height is equal to negative PL. Negative iso na kasi pababa DJ P dito eh. But since da tayo gamin, di 30 kilonewtons tayo pangato, iso nga positive. And the length of your beam is, again, sinorten tayo A to B is, distance from A to B is 6. So ano ulit itong, paano ko nakuha itong rectangle na to? So, nalpas ko na yung drawing, di moment diagram dati 30 kilonewtons. Ti drawing ko tatagaro dan jay moment diagram na daytoy 160 kilonewtons na kilonewton meter nga moment. So again, kitak dito yung diagram from 1 to 4. Anya nga diagram dita or anya nga diagram dita di padpada na kastoy, adatoy di fix, dito di beam ko, tapos ada iti moment at the other end. Anyang pakitype ang pamangag ay nagpigsa ko no. Pakitype di chat box. Okay, so if you try to look here, sa may number 3, at one end is fixed, tapos may moment doon sa isang end. Since baliktad ulit, ang case natin, yung ating fix ay nasa right, tsaka yung moment nasa may left. Ang itsura ng ating moment diagram ay simply a rectangle, and yung height ng ating rectangle ay yung mismong moment. So if you kung ilalagay ko yung height ng aking moment ay, yan, negative 160. Bakit negative? What is my basis? Bakit negative? Ay dito sa may diagram number 3, yung direction ng moment, if you try to look at that is Counterclockwise. Okay, counterclockwise. Since, di ba, from our previous topics, counterclockwise, ang direction ng ating moment ay pababa. Since pababa siya, so, yung ating moment ay nasa may negative. Kung kung clockwise yung moment, ang ating moment diagram ay nasa may positive. Okay? So, nagpasta yun, di jay concentrated, ay jay reaction nga 30, tapos jay moment nga 160. At dapat load tayo, iso daytoy 2 kilonewton per meter na uniformly distributed load. Again, looking at this diagram, tipadpada na daytoy nga loadings. We have here a fixed support. Tapos, meron tayong uniformly distributed load. Itipadpada na dito nga diagram, pagdi number 1. Ang itsura ng ating moment Ang itsura ng ating moment diagram is this one. So, that is a parabolic curve. Papasok ulit dito si spandrel. Di ba, naadal tayo yung previous topics, no, ayan load diagram, that is a straight line, that is a 0-degree curve. Tapos, numapan ijay shear diagram, agbalin nga slanting line, that is a 1-degree curve. Pagdating kay moment diagram, agbalin nga parabolic curve, which is a 2-degree curve. So, dito ayan problem tayo. Dito ayan 2 kilonewton per meter na uniformly distributed load. Pag i-drawing na natin yung kanyang moment diagram, agbalin iso ng parabolic curve, pero second degree curve niya yun. So if I'm going to draw my moment diagram for the 2 kilonewton meter, it will look like this. Again, pabaliktad tayo the orientation na dito yung number 1, G-fix at the dito left. Ngamda tayo gamin, G-fix support tayo at the right. Okay, so pabaliktad diay. Since downwards, DJ direction dito kilonewton per meter, iso nga G-height na dito dito spandrel tayo is in negative value. Kasano ka naala data? I just followed yung ito. Nandun sa my notes. So, negative of the W. Your W here is the 2 kilonewton per meter. The length from A to B is 6/2. So, the height na that is spandrel is 36. Again, negative kasi pababa yung direction na uniformly distributed load. Okay tayo moment diagram pa lang dito I just showed you on how to use yung diagram tapno nabibiit kayo nga drawing iti moment diagrams. Okay tayo?
Yes, ma'am.
This is not yet the final answer. Again, we are trying to get the value of your theta EB. Since naala tayo yung moment diagrams, I need to get the area from A to B. So in ruwar kon daytoy 1/EI tapnohaan nga kasla nga complicated the equation po. Okay? So daytoy 1/2 times 6 times 180. This is the area of 1/2 6 of this blue triangle. Dito 160 times 6, that is the area of this rectangle. Then, itong 6 times 36/3, that is the area of my spandrel. Kasano di area ni spandrel? Subliyan nyo muna di topic yung geometry or di previous topics tayo, na-discuss tayo regard na pasadaan tayo basit it is spandrel. So, for the area of the spandrel, that is base times height over n plus 1. So, yan din yung geometry mo dito. Basta, dito first, this is the area of your triangle. Dito yung area, the rectangle. This is the area of your spandrel. Okay? Again, iso nga ti inalak lang is from A to B kasi po, kailangan kong kunin yung theta AB, which is ang concern ko lang ay sa area from A to B. Yan. Inputting these values in your calculator, my theta AB is equal to negative 492 over EI kilonewton meter squared. Okay, so that is my theta AB. Therefore, may value tayo ng EI that is given in the problem, which is equal to 54,000 kilonewton meter squared. Okay. So my theta AB is equal to 0.0091 radians. And my direction here, negative. Kindly correct this. So, the final answer ko, the slope at B is equal to 0.0091 radians. Do not try to convert your final answer into degrees kasi we are not dealing with angles but rather we are dealing with rotation. Rotation ang pinag-uusapan natin dito. Okay? So, ang direction ng aking slope, since negative the remote nga answer ko, and our sign convention for slope, no negative value, that is clockwise. Okay tayo dito sa first pa lang, slope at B, before I proceed with the deflection at B. Medyo?
Absorbing. Digesting.
Choppy? Choppy, pakitay platan kasi choppy ti dating kanya. Kasano di deflection at B? If I'm going to look at my free body diagram, the deflection at B is this point. Yang distance na yan. From point B, originally, adatoy ni point B. Then, from your elastic curve, napaniso na dyan. Due to your 2 kN per meter. Data ni deflection at B. So, how will I get my deflection at B? Maalak yung deflection at B. So, from that diagram, the division of B with respect to A is equal to the deflection at B. Kasano nga naala dito nga TBA? Dito nga TBA. Di ba, DJ point B, i-giant elastic curve. Dito ni point B, i-giant elastic curve. Nag-drawing naktatay ti tangent line passing through A. Iso dito kulay green nga dito That is a straight line. So from the point B, i-giant elastic curve, hanggang i-giant tangent line passing through A, that is the division of point B with respect to the tangent line passing through A, which is TBA. So from that diagram, TBA is equal to deflection of B. From theorem 2, area A, the TBA is equal to area AB times XB. Dito'y panang-ala yu ti area, di boundary yu dito'y is from the point smooth lang nga inkabel yu dito'y. Since this is TBA, therefore they consider yung nga area is from A to B or from B to A, sumot lang di ay. But for the reference of X, again ulitak di yung bagat tatay, no anya di adatay numerator nga letter, isumat lang di dya ikabel yung nga suffix dito'y tapnuhang kayo nga maulaw. Okay? So that is the equation to solve for the TBA. And if I'm going to draw the centroids for each figure dito yung anti-moment diagram, J distance of the centroid decay triangle hanggang to the point B is 2. How did I get this 2? Again, from your geometry, the centroid triangle is 1/3 of my base. So, dating a distance is 1/3 of your base. Your base is the length, which is equal to 6. Again, baka na, dito 6 na dito, that is the length of AB. Okay? Then, the distance from the centroid of your rectangle hanggang kani B is equal to 3. The distance of the centroid of your spandrel hanggang kani point B is 1.5. How did I get the centroid of my spandrel? Times 6 minus. If you try to nukitan nyo ayan ti sublian nyo di geometry, ti ko na ijay for the centroid of the spandrel, that is dating a distance nga daytoy, that is the equal to 3/4 of your base. Basta second degree curve daytoy Try to go back to your geometry, nakakabili jay, or rigid bodies ba yun? At damat naman yung table na dito. So, the distance ka no, from the longer side, that is equal to 3/4 of base. 3/4 of 6 is 4.5, and ang concern natin is the distance from the centroid hanggang kay point B. So, 6 minus 4.5, doon ko nakuha si 1.5. Okay? So, after na nakuha natin yung mga distances of the centroid hanggang doon sa may point B, we can now substitute the value. Again, itong 1/2 of 6 times 180, this is the area of your triangle. Itong 2 na ito, yan yung distance of the centroid hanggang kay point B. Dito 160 times 6, that is the area of your rectangle. Dito 3, that is the distance from the centroid hanggang kay B. Then dito 6 times 36 over 3, this is the area of your spandrel, multiplied by 1.5, that is the distance from the centroid of the spandrel hanggang kani B. So if we try to substitute these values in your calculator, your TBA is equal to negative 0.0353 meters. Again, anya tikayat na nga sa uwan di negative, DJ deviation tayo ada ije baba ni beam. Okay? So it turned out from our computation, this is negative, which means DJ garo the TBA ada ije baba di original na beam, which is isot ni makikita yun dita diagram. Now, no ija ayan ti free body diagram yo, di deflect di TBA kat ada ije nga to, tapos tirimwar nga kat negative. Kit na nga sa uwan, mali di jay illustration nyo. Okay? Ay, pas. So, since TBA is equal to deflection of B, that is equal to negative 35.3 millimeters. Again, millimeters, di alalagan tayo ng unit of measurement in deflection kasi mas madali siyang ma-imagine kumbaga. Mas madali siyang ma-visualize compared to 0.0353 meters. So, here in theory 1, when we talk about deflections, tapos nagpapada tayo the answer, our units should be in millimeters or inches. Okay? So, that is illustrative problem number 2. Ma'am, at theta AB, han ba included dyan negative sign? Nya di ay? Wan maawatak, nagrigat nga awatan nga dagos tatta kasi short di oras tayo. But after our discussion, sublian nyo dito nga topic. Adalang din nag-question dito'y J ba theta, A, B, han ba included yung negative sign? Now if we try to go back, doon sa may slope B. Doon sa may slope B, kani slope B, di ba tinaala yung answer dito kat negative? Anya ti kunan tayo tatay. No negative di ay sign iti slope nga naalayo. Ti kayat na sa uban, di rotation nyo is clockwise. Okay? Iso nga ti final answer you, jay slope at point B is 0.0091 radians clockwise. Bastahan nyo nga liplipatan no di slope titungtungan, no slope. No negative tinaalayo, that is clockwise. No positive, that is counterclockwise. Okay ba? Na medyo gets, Mr. Tumangman? Oy. Nasolve tayo dito slope at B and deflection at B. Now, here in theory 1, dito sa paggamit ng area moment method, hindi lang naman siya for beam deflections. We can also use moment area method in determining reactions, especially for indeterminate structures. Now, if we try to look at this diagram, itong prop beam na to, this will fall under indeterminate structure. Now, I just want to show you how to use moment area method to determine the reactions. So, for this one, determine the support reactions and the slope at C. So, if we're going to draw the elastic curve of this prop beam, it will look like this. Again, ulitin ko, kapag fix yung support, haan nga dagos nga curve di jay beam or di elastic curve. Pero at a straight line pa lang isuna, then at a certain point, di nga agluging curve isuna. But if your support is either hinge or roller, diretsong curve di ay elastic curve tayo. Okay? So your elastic curve will look like this. Now I'm going to pass a tangent line at point A. Yung tangent line ko sa my point A ay itong line na to na nakikita ninyo. That is a straight line. Then yung tangent line passing through B is this one. Ang hinahanap ko dito is the support reactions and the slope at C. So slope at C is there, as you can see in the diagram. Oh my gosh. So paano ulit natin to isosolve? Now if you wait, isimpak lang wait. Yan yung moment diagram nung R na ito. This is unknown kasi uray mo sa static equations ang ko nga ma-solve DJ reactions kani C kani A. Iso nga usarap iti area moment method tap na makaala iti value DJ reaction ko. Ay tagbalik nga reference ko dito ni point A. Apay nga ni point A ti alaot. Kasi alaot ni point A, da iso lang mabalin ko nga alaan nga reference point, since ni R dito'y, this is due to the load coming from the uniform distributed kanjay moment dito'y. So, pagbalik ang ati reference ko kat ni point A, dyan ko nga ikabel di fixed support. Di ba from the GMP diagrams that tayo, ngayon pag-present ko kanya yun, yung 1, 2, 3, 4. Since this is a concentrated load, fixed support, ito'y left side, tapos concentrated load ng pangato. The moment diagram you will look like a triangle, but since pangato the concentrated load, the triangle mo nga rutata is sloping upwards. So, the agbalin na height, iti triangle mo is na distance 8 multiplied by the value of your concentrated load, which is R. Okay? Since itinagbalin na reference ko gamin kat dito ayan ti point A, ag zero out amin dito yun. Ano nga papakialaman dahil dati nga side. At na kayo nga maulaw. So, ti concentrate yun na lang kat dito ayan ti right. So, naala ko di moment diagram na dito R. I need to get the moment diagram of this 12 kN per meter. Again, from the diagram that is in your notes, the height of my spandrel is negative 12 times 4 squared over 2, which is equal to negative 96. Yeah. Next, I need to determine the centroid of these shapes. And this, hanggang dun sa my point C. Apay nga point C, itinagbalin nga reference ko. Di ba, no basa ang gamin dito yung problem, slope at C. From that word C, ito kahit nagag na sa ugod, dito ito pagbalik na karet nga, ije ko nga alagan di area, taknuhan na ka problema. Di ba, from theorem 1, di theta, let's say ni A to C, that is equal to the area from A to C over EI. Since the slope ni C ti biru-biru ko, maalak di slope ni C, basta amok di area from A to C. Iso nga iti ala ang distance tata, di distance from the centroid hanggang ni point C. And again, look, from your geometry, di ko nga naala dagiti nga values. So, di TCA, anya dito nga TCA, apay nga nag-0 di TCA. Apay nga nag-0 out di TCA. Kada apay nga kailangan di TCA. 0 di TCA. Now, if we try to look at this diagram, a giant elastic curve at that 20 point C, and the tangent line at point A, straight line isuna, eksakto mo nga nagnaisuna ka ni point C. So, awan ti makita yung value na, kasi nagsabat na meeting point na ni point C. Therefore, I can say that the division of C with respect to A is equal to 0. And TCA from theorem 2 is equal to the area from A to C multiplied by XC. So, the area from A to C, that is equal to 1 over AI. Itong 1/2 of 8 times 8R, this is the area of your triangle. Ito naman ay yung distance ng centroid ng triangle hanggang kay point C. Itong 4 times 96 over 3, this is the area of your spandrel. And this 7, that is the distance from the centroid hanggang dun kay my point C. Therefore, my TCA, di ba TCA tatay is equal to 0, so ma-solve ko GR, which is equal to 5.25 kilonewtons. Dito nga R nga data, that is the reaction at point C. Okay? So again, as you can see, pwede mong gamitin ang area moment method to solve for reactions, especially for crack beams, which is an indeterminate structure. And we can determine the other reactions also, this summation of forces along the vertical axis. Your RA is equal to 42.75 kilonewtons, and your MA is equal to negative 54 kilonewton meter. Okay? So those are the support reactions. Now we can determine the slope at C. For the slope at C, that is equal to the area AB over EI. Um, take note, iji theorem 1, ti ko na nagamin iji theorem 1, delta AB is equal to the area from A to B over EI. Now, be careful with this one. Dito nga theta AB, no, di ba, no, sublian tayo di diagram tatay, no, dito di elastic curve. This is your elastic curve. Dito ni point A, dito ni point B. Tapos, nung nag-drawing na ti tangent line passing through A, tangent line passing through B, di jay angle between the tangent lines, data nga slope, data ni slope AB, ti equation na daytoy, dayjay. Ngam, di equation na dayjay slope ditoy nga banda, ditoy slope ni B, that is not equal to this equation. Okay? Ngam, apay ngay ditoy garod. Nga di slope ni C is equal to area AB. Area AC should be over EI. Apay nga kasta tinagbalin nga equation ko. Nang nukit kita nyo gamin i diagram. Di angle nga nagsabatan ni slope ni A kan di slope ni C. Diba dito di tangent line ni A. Dito di tangent line ni C. Di nagsabatan da nga angle. So dito isumot lang ni theta C. So no i-drawing ko ulit di ay, no dito di tangent line ni A. Dito di tangent line ni C. Diba di angle between them, dito di angle, dito di slope ni A, C. Tama? But, if you try to look at the diagram, this theta AC is the same as theta C. Therefore, the theta AC, the equation ko dita, which is equal to area of A to C over EI, is the same equation tapno maalak di theta C. So the area between A to C, again that should be area between A to C. The area between A to C is this one. Dito 1/2 times 8 times 8 times this one. That is the area of your triangle. And this one, that is the area of your spandrel. Therefore, the slope at C is equal to 40 over EI.